All right, so today we're going to talk about absolute value equations. This is going to be completely new. You all haven't seen this before, so let's go ahead and get started, okay? So, what does absolute value mean? What is absolute value? Absolute value, if you all can recall from last year, is a number's distance. And for this particular case to start off with, we're going to talk about just the basic part of absolute value, which is a number's distance from zero. Now, when I say that's the basic part, because it could be a number's distance from one, it could be a number's distance from two, it could be a number's distance from -4. Okay, so usually when we think about absolute value, it's just a number's distance from zero. But I'm letting you know now that absolute value is just distance from any number that you want to specify, guys. All right, so I'm going to put absolute value represents a number's distance from any other value or number, okay? Usually that value is zero. Okay, that's basic absolute value, but it's not always zero, okay, guys? All right, so I'm going to put usually it's zero. All right, so let's take a look at number one, and we're going to talk about an absolute value equation. We're going to talk about how you read it, and I need you to read it in a way where you can say distance instead of absolute value, because absolute value is just distance. And then we're going to talk about what the graphs and solutions are, okay? What the graphs look like and the solutions are. So most people, when they read number one, if they read this, they'll say the absolute value of x equals 3. Absolute value, these are your absolute value symbols, of x equals 3. That's what most people will say. All right, but there is another way besides saying the absolute value of x equals to 3. How can we read this equation without saying the absolute value of x equals to 3? Well, instead of using the words absolute value, we're going to use distance, okay? Now, the distance, it says from any other value. Well, if you want to figure out what distance you're talking about, from what number you're talking about, you look inside of the parentheses. So look, not parentheses, but absolute value. Sorry, guys. Basically, this is the distance between x, which is, I'm going to say x is some number. We don't know it. That's why we're using a variable. The distance between some number and 0. And you all, when we find distance between numbers, we use subtraction to indicate that distance between two numbers, okay? So that's why you see that minus sign there and not a plus. Because if I'm looking for the distance, and don't write this down, if I'm looking for the distance between 2 and 7, 2 and 7, I can just take the absolute value of 7 minus 2, which is the absolute value of 5, which is 5. Or I could say the absolute value of 2 minus 7, which is -5. But the absolute value of -5 is 5. That's because distance can never be negative. So that's another reason we use these absolute value symbols, to ensure that we don't get a negative distance, okay? But of course, my point being is that whenever we find distance between two numbers, we just use the operation subtraction. Hence, that's why we're using subtraction here, okay? Now, instead of you being able to see this 0, see, if you look right here, there is no 0 in that. It's just x. But whenever you just see the variable, it leaves the 0 off, because we don't say, if we say 5 plus 0, we don't leave it as 5 plus 0. We just say 5, or 5 minus 0. We don't have to have the 0. We just can write 5, okay? So if you say x minus 0, we just go with x. You don't need the 0. So that's why you only see the absolute value of x. But basically, what it is the distance, absolute value. You got to say the distance whenever you see absolute value between, and here we go, x, which is some number. And what other number? Well, the other value in here that you don't really see is 0. So the distance between some number and 0, and it tells us equals 3. So that's how we're going to read it. So when we see these absolute value symbols, we're going to say the distance between, and then we can go with what we see on the inside. On the inside, I see an x. And so instead of saying the distance between x represents some number. The distance between some number and what other value? Well, the other value in there is 0, although you don't see it here. It's a 0. The distance between some number and 0 equals, well, what is it set equal to? 3. So you're just going to think in your mind, the distance between what number and 0 is 3. Okay, I just need the distance between some number and 0 to be 3. Well, what number, we're going to look over here, is 3 units from 0? So that would be the number 3, because it's 3 units from 0. 1, 2, 3. From 0, okay? And there's another number that's 3 units from 0. It has a distance of 3 units from 0. And that would be -3. -3 is 1, 2, 3 units as well. One is just on the negative side, the other's on the positive side. Or one is just to the left of 0, one is to the right of 0, okay? So there are two numbers that are 3 units from 0. That would be the number 3 and -3. And you don't have to put the negative sign at the and sign. You can just do 3 comma -3, like that. Sometimes you will even see this, not like that, not with the parentheses, but with the curly braces. That means +3 or -3, okay? So those would be the numbers that are 3 units from 0, 3 and -3. So the distance between 3 and 0 is 3, and the distance between -3, -3 and 0 is also 3. All right, let's take a look at how we can read the second one. So how can we read the second one without saying the absolute value of x equals 5? I know this absolute value of x equals 5, but absolute value is also distance. Okay? So I'm going to say, when I see these absolute value bars right here, I'm going to say the distance. The distance, I'm always going to start my sentence off like that. The distance between, and then we'll go with what we see on the inside. Well, what's on the inside of the absolute value bars? What's in x? But x, we don't say the distance between x because x is an unknown, and we use that unknown as to represent some number. So we're going to say the distance between some number instead of the distance between x. The distance between some number and what? Well, look on the inside. Okay. That x is the same as x minus 0. So basically, it's the distance between some number and 0 equals 5. Now, you're just going to think to yourself, what number is 5 units away from 0? So it says the distance between some number and 0. So I got to pick a number that's 5 units from 0. Okay, so that would be the number 5. And you can see 1, 2, 3, 4. That's 5 units from 0. But what other number is also 5 units from 0? Well, that would be -5. 1, 2, 3, 4, 5. And it's all from the 0 mark, okay? So the distance between -5 and 0 equals 5. And the distance between 5 and 0 also equals 5 units. Okay? All right, so my two answers are 5 and -5. Or you can write it like so. Okay? All right, let's take a look at C. C is a little different. C says the absolute value of x minus 1 equals 3. Okay, but I don't want to read it that way. How can we read this equation besides saying the absolute value of x minus 1 equals 3? Well, I told you whenever you see absolute value bars in there, they go. You start your sentence off with the distance. The distance between what? Well, it's got to be between two values. And one of those values is x. So we say some number. The distance between some number and what other value? Okay. Let's think about that. Well, if you go back to A and B, it was the distance between x and 0 because there was nothing there. So I told you all x minus 0 is just x. But it helps us to see is the distance between x and 0. Okay? The distance between x or some number and 0. Well, look at these two. It's the distance between some number and not -1, 1. Because the subtraction sign that you see in the middle represents distance. Okay? That subtraction sign just represents the word distance. So when I said the distance, that takes care of that subtraction sign. So the other two values have to be x and 1. Okay, or some number and 1. And what does it equal? It equals 3. Now, if you look at the graph, instead of trying to figure out what number is 3 units from 0, I'm trying to figure out what number is 3 units from 1. So we're going to go to this one. What number is 3 units from that? So, that's going to help you process the distance between some number and 1 has to be 3. So you got to go out 3 units. So that means the distance between 4 and 1 is 3 units. Okay, there's another number that's also 3 units from 1. Now, most students would think, oh, -4. Okay, don't draw this or don't write it. Well, is the distance between -4 and 1 3? Well, let's check. 1, 2, 3, 4, 5. That's not accurate. Now, let me tell you why most people want to put -4. Because up here, they saw +3, -3. +5, -5. They saw a number and it's opposite for the solutions. But that's only because it was the distance from 0, and 0 is a neutral number. Okay? So you can have a positive number and it's opposite. Okay? But here, this is 1. Okay, so I'm going to go back. What number is 3 units from 1 besides 4? Well, 1, 2, 3. -2 is also 3 units from 1, guys. -2 is 3 units from 1, and 4 is 3 units from 1. So those are my two answers. Again, don't be so quick to put +4 and -4. Okay, we're not talking about the number's distance from 0. This is a number's distance from 1. Has to be 3. All right, let's take a look at D, guys. D says, besides saying the absolute value of x minus -3 equals 4, how can we read this? Well, here's my absolute value bars again. So we can say, and let me go back over something. Hold on. Instead of putting these up here, y'all do me a favor. Maybe this will help you on that last video I showed you. The answers are -3 and +3. Put dots. And here, you put a dot on -5 and +5. And on C, put a dot on -2 and +4. Okay. All right. Let's go back. Sorry. All right. So here, and those dots just are my answers, guys. Okay. All right. So I'm going to say, because I see absolute value, I'm going to say the distance between, and I'm going to go ahead with some number because I see the x variable. I know I got to have and because I have some other value. Okay, now keep in mind I said if you say the word distance, that means that's the minus sign in the middle, okay? Because we find distance by subtracting or using a minus between the two numbers. So if you subtract what two numbers, okay? Some number and what else? Okay, so you just kind of look at it like this. If you subtract some number, which is an x, and what? Well, the other number, if you subtract x and not 3, but -3. If you subtract x and -3, so the distance between some number and 3, guys, not 3, -3, I'm sorry. That's a -3. If you find a distance between some number and -3, it should equal to 4 in this particular case. That's what that statement says. So I'm trying to find the distance between some number and what other value? -3. So I'm going to go over here and find -3. I know it's got to be from -3, guys. So what number is 4 units from -3? Well, there are actually 2. Let's just count over and see. 4 units from it. 1, 2, 3, 4. 1 is 4 units from -3. Put a dot, guys, on 1. And what other number is 4 units from -3? So let's go back to the left and see. From -3. 1, 2, 3, 4. -7 would also work. So your two solutions are 1 and -7. Now let me show you something, guys. Please, please, please pay attention. I wrote D like this to help you realize that minus a negative, right in here, if you do minus a negative, it's the same as a plus. You will never see an absolute value equation or inequality, we're going to get into those later, written with minus a negative. It will just be written as a plus. So some students will say, oh, the distance between x and 3, if they see it written like that, okay? The distance between x and 3 is 4. The distance between some number and 3 is 4. That's not really 3, because in order to say distance, you got to have a subtraction sign that's a plus sign. So what subtraction problem gives me a +3? Well, minus a -3. So now I know it's the distance between x and -3. But again, the point I'm trying to make is, although I wrote the original problem like this, you will never ever see it as minus or negative. You will only see it as plus. Okay? All right, now, what we want to do is keep in mind what answers we wrote for these. So I'm going to flip over. You all flip over. We're going to focus on C and D only, okay? C and D only. So the answer for C was -2 and 4, or the answers. And the answers for D, they were 1 and -7. So let's write that over here. All right, so what I want to do is figure out mathematically how can I find these answers using just algebra or arithmetic, solving an equation. So without going through the reasoning process to the number line to the solution, what could I do mathematically without using a number line or graph, okay? All right. So this says what you're going to do, and you don't have to pay attention to that first sentence. I want you to start right here. Basically, what we want to do is set the expression inside the absolute value symbols equal to one positive value and one negative value of what's on the other side of the equal sign. All right, if we set the equation equal to one positive value and one negative value of what's on the other side of the equal sign. When I say the equation, I'm talking about what's on the keyword inside of the absolute value symbols. Got to be on the inside, okay? All right, so we set it equal to one positive and one negative value of what's on the other side of the equal. We're going to end up with two separate equations that produce our solutions. All right, and these two equations are going to be called compound equations. The reason they're called compound equations is because we're going to have two equations, okay? And you're going to find out specifically that when we get to compound inequality equations, they're actually going to be joined by conjunctions like and or the word or, okay? An actual conjunction. All right, but let's take a look at C and see if we can reason what I'm talking about. So I'm going to focus on the inside. What's on the inside of the absolute value? That would be the expression x minus 1. Then it says, take that expression and set it equal to one positive value. Okay, positive value. Well, the only other value in that equation is 3, so I got to set it equal to the positive value of 3. But I also need to take that expression that's on the inside of the absolute value and set it equal to the negative value of what's over here. So the expression that's on the inside again is, I'm going to put an and symbol, guys, is x minus 1. So these are going to be my two equations. But now I got to use the negative value. Here I use the positive value. Now I want to use the negative value. So the negative value of 3 will be negative 3. Now I have two equations. And those two equations, when I solve, are going to produce the answers negative 2 and 4. So let's take a look at this one. If I solve for x, I just add 1 to both sides. So x is equal to 4. There's that solution. And I'm going to have to erase this and put two equations here. Here I'm going to add 1 to both sides. And x is equal to negative 2. That produces that equation. So these are pretty simple to solve. All you do is take what you see on the inside, take that inside expression and set it equal to the positive version of 4 and the negative version of 4. So I'm going to take my inside, x, and instead of minus negative 3, I'm just going to put plus 3 because that's what it is. And take what's on the inside and set it equal to the negative value, okay? And then you solve both. Subtract 3 from both sides to solve for x. There's that 1 that we ended up with on the front page. All right, subtract 3 here. There's negative 7. That's it. All right, let's keep rolling with it. So I hope you understand that. If not, I have more directions here. It's just those same steps. Make sure the absolute value expression is isolated. And the reason I say that is because sometimes you'll get these equations that look like this. Okay, so when I say make sure the absolute value expression is isolated, if you look over here, this is the expression that contains the absolute value, but it's not on the side by itself. Over here with the absolute value expression, I have a negative 2. This is not isolated. If I wanted to isolate this expression, this entire expression, I would need to get rid of negative 2. So that's the first thing we want to do is make sure that that absolute value expression is on the one side of the equal sign by itself. If not, you'll need to use an inverse operation to get the entire absolute value expression on one side of the equal sign by itself. So the inverse of negative 2 would be positive 2, and you have to do that to both sides, okay? So once you get that absolute value expression by itself, the second thing you're going to do is take what's on the inside and set it equal to both the positive and the negative value of what's on the other side of the equation. And then you're going to solve both. So we're just going to take a look at these real quick. Look at 1, 2, and 3. I'm going to take a look at these and I'm just going to ask myself, is there anything, I'm trying to erase this. Is there anything else on the side where the inequality is? Like here, the inequality is on the left side. Is there anything else over there besides that? Excuse me, not inequality, absolute value. Is there anything else on the left side besides the absolute value expression? No, it's already isolated. So I can just take what's on the inside. I'm going to set my two equations up over here. What's on the inside? Well, on the inside, you simply see the x. That's it. X is on the inside. So x equal to the positive version of 2. And x equal to the negative version of 2. There's no work to do on these. X is already by itself. So your solutions are just positive 2 and negative 2. You're done. On 2, what's on the inside? Well, first of all, you always check. Is this absolute value on the left? Is it isolated? Is there anything else on the left side? The answer is no. So I get my two equations, set them up. M equals to, well, you think about 0. 0 is a neutral number. It does not have a positive or a negative value. It's neutral. So all you can write is M equal to 0. Basically, the distance between some number and 0 is 0 units. But 0 is the only number that's 0 units from itself. Let's take a look at 3. 3, look over here on the left side where your inequality symbol is found. Is that, not inequality, I keep saying that absolute value symbol is found. Is that absolute value expression over there by itself? Yes, so I can proceed to my two equations. If not, you would have to solve to get the absolute value expression by itself. Okay, what's on the inside? 5z. And you're going to set it equal to the positive version of 40. And you're also going to set 5z equal to the negative version of 40. And you'll just use an inverse. The opposite of multiplying by 5 is dividing. Okay, and you do the same thing here on the second equation, and you get negative 8. So your answers are positive 8 and negative 8. You can also put the plus or minus. All right, I need you to pause the video. We're not going to do all these. You're going to pause the video and try 4, 6, and 8 for me, okay? 4, 6, and 8. All right, this is what you should have gotten. If you look, the absolute value expression is already isolated. I can set up my two equations, which would be negative 7a equal to 28 and negative 7a equals to negative 28, okay? Here I'm going to divide both sides by negative 7. So a equals to negative 4. Here I'm going to divide both sides by negative 7. And a equals to positive 4. And that's all you do. So I'm just going to put a. The value of a is plus or minus 4. Or you could have separated and put positive 4 and negative 4. Let's take a look at 6, guys. 6, this is already isolated, that expression, so I can set up my two equations. My two equations will be w minus 3 equals to the positive version of 4. And, make sure you use and w minus 3 equals to the negative version of 4. Isolate w by adding 3 to both sides. So w has a value of 7. One solution is 7. The distance between 7 and 3 is 4. Okay. Let's take a look at this one. Add 3 to both sides. The distance between -1 and 3. Sorry, guys. It's also 4. So my answers are 7 and -1. All right, on 8, I'm going to take a look at this absolute value expression. It's already isolated. So I'm going to use -2v minus 5 equals to 17. And -2v minus 5 equals to the negative version of 17 to find my solutions. This is a basic two-step equation. You're just going to add 5 to both sides. Here I get 22. Divide both sides by -2. And one of my solutions would be -11. Okay, go here. Second equation, you're going to add 5 to both sides. So you end up with -2x equals to, that's left and right. That'll be -12. Divide both sides by -2. And x is equal to 6. So my two solutions are -11 and 6, guys. All right. So I want you to take a look at number 9. Number 9 is just a strange problem. Okay. So I want you to take a look at number 9 and tell me why number 9 is different from all the others we've worked. It's one thing that makes it different. And if you figure it out, you can pause the video and raise your hand. I might give you a treat, okay? But you gotta figure it out before I tell you in this video. So pause it, and I'm gonna check to make sure I didn't say it, okay? Some of y'all be trying to rewind. Never mind, no treats, but just see if you can do it. So you can figure out what's different. Okay, all right, this is what you should have figured out. All these absolute values were set equal in the very beginning to a positive value. Well, 0 is neither positive nor negative, but the main thing is it's not negative. That's 40. That's not negative. 28 is not negative. 4 is not a negative number. 17 is not a negative number. Then you get here, and there it is. It's set equal to a negative number. Okay, now, guys, I'm not even going to solve this problem. It's absolutely zero work to do on this. And there's one reason. But you will not comprehend this if you do not know what absolute value means. So absolute value is distance. Okay? It's basically distance, guys. So this says it's absolute value. So basically, I'm just going to use the word distance. Some distance is or equals -8. That's what that says. Regardless of what this is, it's an absolute value, so it has to be distance. So some distance is equals some negative. But let me ask you all a question. Can distance ever be negative? That's the question. So I'm going to use the same example I used with you all last year. When I'm talking about distance, I was talking about distance. I drive about 20 miles to work every morning. Okay? And I go west, 20 miles west. Now, when I leave the school and come back home, I'm going east. I don't get in my car and say, well, let me drive my -20 miles back to the house. Okay? Because distance can never be one thing. Distance can never be negative. Ever, ever, ever. Distance can't be negative, guys. Okay? All right, so anytime you see an absolute value expression that is isolated, it's got to be isolated now. Anytime you see an isolated absolute value expression, and that's already on this side by itself, anytime that isolated absolute value expression is set equal to a negative, don't work it. Just put the answer is no solution. Or you can draw the empty set notation, okay, for no solution. All right, if you don't understand that, pause the video and call me over. All right, we'll take a look at, we'll go to 14. Okay, here we go. So let's work with some fractions. So I'm going to take 2/5 x minus 2/3 equals a positive version of 1/6. So I can already go ahead and set this up because this absolute value expression is isolated, guys. And then I'm going to take 2/5 x minus 2/3, set it equal to the negative version of 1/6. Now, I have taught you all how to get rid of these multiple fractions if you don't like working with them. So we're going to use that same strategy that you learned to get rid of multiple fractions, which is multiply the numerator by the common denominator and divide. Well, the common denominator between 5, 3, and 6, guys, is 30. I'm just going to say that's the CD, common denominator. So what I do is multiply the numerators by 30. Go through on all of these. Let's just go ahead and just set it up on this side. So 2 times 30 is 60, but 60 divided by 5 is 12, so that's 12x. 2 times 30 again is 60. 60 divided by 3 is 20, but that's minus 20. 1 times 30 is 30. 30 divided by 6 is 5. Over here, you're going to end up with the same thing, except instead of a positive 5, you're going to end up with a negative 5. Okay? If you're unclear on that, let me know. All right, so I'm going to solve here. So I have 12x equals to 25. And it's okay if you don't end up with a whole number. That's fine. So 25 divided by 12 would be 2 whole groups of 12. It's 24 and be 1 left over. 2 and 1/12, guys. Okay, let's take a look at this one. Let's add 20 to both sides. So 12x equals to 15. Divide both sides by 12 there. How many groups of 12 can you get out of 15? That'd be 1, and then 3 will be left over. But I'm just going to write this as a simplified fraction, 1 and 1/4. So my two solutions are 2 and a 12th and 1 and 1/4. All right, if you have any questions, let me know. Okay, I'm not going to work 11. 11 is pretty simple. You just set it up with a decimal though, okay? No big deal. I will show you like how it should be set up. This is already isolated on one side of the equal sign, so you would have set it up like so with your 2, 23.34, and then the inside of the expression equals the negative version of that. And you just would have solved by adding 42 and 400s to both sides. I'm not going to solve it. I hope everybody knows how to add and subtract decimals. They must be lined up. But down here, when you subtract, you got to go back and put the 42 and 400s on top because 23 is a smaller decimal, okay? All right, let's take a look at 12. Okay, this is pretty logical. Like, what number, the distance between 2/3 and what number is 0? Well, what number is 2/3 away from 0? Well, it'd be 2/3, okay? So let's take a look at it. All right, so here, I'm going to take the inside because this is already isolated. So I'm going to take 2/3 x, not x, 2/3 minus x, and set it equal to 0. Now, because 0 is a neutral number again, we can't say negative 0, guys. It's not even positive 0, it's just 0. So anytime you have an absolute value expression set equal to 0, an isolated absolute value expression set equal to 0, you're only going to have one solution, okay? So what I'll do is subtract 2/3 from both sides. these will cancel. But that's an imaginary -1. And 0 minus 2/3 is -2/3. Basically, I divide both sides by -1, but I know a negative divided by a negative gives me a positive. So there's only one solution on these, okay? Again, whenever you have an isolated, this has to be isolated on one side. It has to be isolated. And it's set equal to 0. You're only going to end up with 1. I'm going to put SOL for solution, okay? Let's see, we got the same thing up here. See, look at this. Yeah, that was too simple. All right, let's take care of these last two. All right, so we're going to use the same line of reasoning to solve these. But if you look on the left side over here, your absolute value expression is not isolated. You got some other stuff over there with it. So what do? So what about this other stuff? Okay. What we're going to do is use an inverse operation to get rid of it. So how do we get rid of this other stuff, which is +2 on the other side? Using the inverse of +2, which is -2. These will cancel. Now when you bring this down, now the absolute value is isolated. So I'm going to put the absolute value of C equals to 12 minus 2, which is 10. Now I can write the two inequalities. Now I can go with the absolute, not absolute, but C. You got to go what's on the inside. Please don't put the absolute value. Just put C equals to 10 and then do the negative version. C equals to -10. 10 and -10. Okay? All right, let's take a look at 14. 14 is this expression isolated. Nope, it's got a -8 over here with it. So I'm going to isolate first. I don't need to draw that bar that line. I'm at that long because I need to isolate this. And then I can write my two equations. All right, how do I get rid of -8? I add 8 to both sides. So I end up with 3 equals to the absolute value of y. Okay? So in the beginning, that expression was not isolated. Now it is isolated. So once it is isolated, then you write your two expressions. Now I'll go with y, which is on the inside, equal to 3, and y, which is on the inside, equals to the negative value. So plus or minus 3 is your answer. +3 and -3. And that is all you do, guys. All right. This is taking long enough. That's part 1. There are two other parts. You're going to have a part 2 and a part 3 tomorrow. And then you can work on homework, okay, after you finish part 3. All right, that's it for right now. Thank you.